So welcome to the topic quadratic sequences. So previously we dealt with linear sequences. Now we take it up a notch. We're going to look at quadratic sequences. Whenever you hear the word quadratic, I want you to associate it with the power 2. So you'll see why. So the general form of a quadratic sequence, we're going to write Tn is equals to an squared plus bn plus c. This is the general form of a quadratic sequence. This is the shape that it takes. So we are all going to be dealing with this. So a typical question might say a quadratic sequence 6, 10, 16, 24. This is a quadratic sequence 6, 10, 16, 24. Show that its nth term is n squared plus n plus 4. Show that its nth term is n squared plus n plus 4. So what are we going to do? Let's rewrite the sequence 6, 10, 16, 24. Let's try finding the common difference. So between 6 and 10 have another plus 4. For us to go from 6 to 10, we add 4. How we are going to add 6? 10 and 16 is the difference of 6. How we are going to add 8 plus 8? So we don't have a common difference, a constant difference like linear sequences. But then we can go on to do this. There is a common difference now in this smaller sequence. So have a difference of 2. These numbers at the front are of interest to us. These are useful to us. So we are going to use these numbers to find the general term, to show the nth term. We're going to end up here after solving this. So we have to look for A in this equation, we have to look for B, we have to look for C. So how are we going to look for A? We're going to use this number. Let me just go ahead and write the 2A. I'm going to write 3A plus B. I'm going to write A plus B plus C. So I'm going to use these numbers. Let's start looking for A. So 2A is equals to 2. Divide by 2, A and now 1. Then let's look for B. I'm going to use 3A plus B is equals to 4. 3A plus B is equals to 4. We do know what A is 1, so let's go ahead and substitute. 3 open brackets 1 plus B is equals to 4. 3 plus B is equals to 4. Take 3 to the other side across the equal sign. Originally B is equals to 4 minus 3. Originally B is equals to 1. Let's look for C. A plus B plus C is equals to 6. A plus B plus C is equals to 6. A is 1. B is 1. C unknown 6. 2 plus C is equals to 6. C is equals to 6 minus 2. C is equals to 4. Let's bring it all together now. Remember, this is the general form. Tn is equals to an squared plus bn plus c. A you are like a 1, so 1n squared. B you are like a 1n here plus c 4. So all in all, renally n squared plus n plus 4, thereby answering this question. The question goes on to say, hence find the term that has the value 136. We are looking for the term with the value 136. So Tn is equals to n squared plus n plus 4. Find the term that has the value 136. There is a term okay, high. It has the value 136. So I can substitute the term 136 and I value of 136 is equals to n squared plus n plus 4. We are going to solve a quadratic equation here. So we are going to solve for a quadratic equation. In order to solve for a quadratic equation, you have to do this. You have to ensure that on the right hand side there is only 0. So in other words, n squared plus n plus 4 minus 136 is equals to 0. We've moved this 136 to the other side. Now it became negative after moving across the equal sign. So in n squared plus n 4 minus 36, that's negative 132 is equals to 0. So let's go ahead and solve for this quadratic equation.